Welcome back. This is John P. Kelleher, and I'm from Los Monados College, and I am now teaching Fire 103, which is the Fire Protection Equipment and Systems class. All the material is on Canvas, and this is a supplement, and it's a good idea to watch this because this is a big lecture on Fire 103 and protection systems. In any case, make sure you look on Canvas, look at the PowerPoint that's on Canvas, and that's the lecture on part 1 called sprinklers. I will have 6 parts in this class. This is a big part. This is probably like 3 or 4 weeks of the class, so it's long-winded. So you may want to watch this, take a couple breaks, pause it, and again, this supplements the PowerPoint, okay? Before I go into the lecture, I want to go over a couple of items. One being the material I use, where I got the reference material. That's the book I used. That's the 3rd edition, Fire Detection and Suppression Systems. Okay, Fire Detection and Suppression Systems. Got a lot of material out of that. And then I also used the new one, which is the Fire Detection 2nd edition, which is much smaller, a little more modern, but in all honesty, and then I use other reference material. I use both books and other reference materials, so I kind of encapsulated everything to make this class, very detailed, and you get a lot out of it. Again, before I go on the lecture, I mentioned material that's on the Canvas. I may have to email this to you because I don't know if I can download this or not, but I show this PowerPoint and 2 videos on Station Nightclub. I was trying to download the video on sprinklers. We'll try and put that on email, or if I can get it on Canvas, so be it, but I'll let you know via email. In any case, you'll be seeing the Station Nightclub PowerPoint. That's where what happened on Rhode Island, probably a couple decades ago, where over 100 people passed. Very sad, but the idea is we broke down and we learned a lot from it when we made things better, i.e. Sprinklers. I show it in the fact that it enhances the reasons why we use sprinklers. In any case, I want you to show you I want you to first watch the Station Nightclub PowerPoint, and all you need is watch this, read the slides 9 through 32, and you kind of breeze through them. You see pictures and a breakdown of what it was like and what it wasn't. I can't teach it, so again, what I want you to focus on is how understand the layout of the building, the before and after, obviously, before the fire, and it was before the fire and obviously the fire. How it was built and remodeled at one point, but it was not up to code or appropriate fire prevention, and safety measures, i.e. proper exiting and assembly listing, and also sprinklers, okay? Then you're gonna watch a video. There's 2 videos. One video is the non-sprinkler video, and the other video is part 2, the sprinkler video. And what they did with that is they made a large scale room of what the Station Nightclub was like, and they showed what the fire actually probably happened. Nobody's in it, of course, but they showed it and what exactly happened to the fire, where the pyrotechnics took off, activated, and how the fire took off from there. And again, it's all simulated. It shows the behavior of the fire, how the fire started, took off, and they'll have a clock on it, and how the fire banks down, which you'll probably learn about in fire behavior, about thermal balance and such, and how the fire banks down until finally it flashes because it reaches its full ignition temperature, and that's maybe 3 or 4 minutes into the situation. So that's the non-sprinkler video, and then they'll show the sprinkler video, and that's where the sprinklers will activate over a minute or 2, and they'll put the fire out. Meaning, if it had sprinklers, wouldn't happen. Okay, so that's a Station Club PowerPoint and the Station Club video, non-sprinkler, and then the video of sprinkler. Okay, so watch that. And again, if you have any questions, email me or text me. You know the numbers, I have it listed. And ask me any questions, write it down, then we can go over it, okay? Again, I'm not here to talk about it, but I usually hand this out. This is a schematic. I'm gonna start going into my lecture now. And again, I'm going over 6 parts. This is the first part about sprinklers. It's about 3 or 4 weeks of the class, so it's pretty long-winded. So you may want to take a break occasionally. Obviously you get tired of me, okay? I don't blame you. In any case, here's the schematic of a typical automatic wet pipe sprinkler system. Okay, and I usually hand this out. You'll be tested on this, so you may want to freeze it and write down some notes or something like that. I'm going to go over each one. And so what that is you're going to have On the bottom here, that's going to be where the water supply is, right down here, water supply. Then it's going to go, there's one pipe going up. They call it going up, calling the riser. Okay, need to know that. And off the riser is all these different parts. And one part is the main control valve, the alarm control valve, the main drain, the fire department connection, the FDC we call in the fire service, the check valves, and that's all on and then the water flow alarm up here, and that's all on the riser. And the riser will rise all the way above to the very top. Okay, we call that the riser. And then the water supply, so know that. Then you're going to have off the riser, you're going to have what they call, or you'll see the water flow alarm here. You see on the outside, it will activate. You see a lot of those on education, on schools, where the water flows through it, and you'll hear like this ding, 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 as water flows through it. Okay? Then as the water rises up into the riser, it's going to branch off into what they call the cross main. Right here, here's the cross main, running cross main here, like so, the cross main, okay? And then from the cross main, it's going to branch off into the branch lines. And these branch lines are right here, okay? And then off the branch lines are the sprinkler heads. And you see these little dots, and that's the sprinkler heads, okay? So that's your schematic of a typical wet pipe sprinkler system, okay? Let's take a picture of that, take a look at it, see what you think. You'll need that later on for the test, all right? And again, as I lecture, you'll need to know what you need to know. I mean, you'll see it again. You need to understand it because you may see it again in your career. And then obviously you don't really know, just get through it and such. It's not important, but it's relative, okay? But again, what you need to know is you'll see it again, and what you need to understand is you may see it again in your career. That's how basically I teach. Okay, so let's start. Let's do part one of these sprinklers, okay? And again, it's on your PowerPoint. Sprinklers have been providing fire protection for over 100 years. Know that, 100 years. Sprinklers are installed in schools, healthcare facilities, high-rise buildings, commercial and residential occupancies. Know that too. In these documented statistics from 1984 to 1987, 29% of the time it took only one sprinkler head to put the fire out. Okay? 75% of the time, 75%, or it's actually 25%, 25, 75, 29% of the 25% of the time, 29% of the time it only took one sprinkler head. 75% of the time it took 10 or less sprinkler heads to put the fire out. So understand 25%, 29% of the time it took one sprinkler head. 75% of the time, 75% of the time it took 10 or less sprinkler heads to put the fire out. Sprinklers fail to control or extinguish the fires because of these reasons. 1, closed valves. 2, frozen water supplies. 3, inadequate water supply. 3, obstructed sprinkler discharges. And 4 and 5, impaired sprinkler heads. Something's wrong with the sprinkler head. So know that as well. Building owners choose sprinklers because of 3 items. Why do owners want to sprinkler their buildings? Because of 3 reasons. 1, fire code requirements. Uniform Fire Code, which is basically the code for all buildings concerning fire and how these buildings have to adhere to legally and such to make sure they're built correctly and safely. The Fire Code requirement, certain buildings need to be sprinklered. The insurance purposes, meaning that they save on insurance if you have a building code, if you sprinkler the building. And then lastly, general fire protection, meaning you're just making the building safe. Fire codes require them when a building exceeds a certain size. When you get such a size of the building, it may need to be sprinklered. So not just a commercial occupancy like a Home Depot or Target, but maybe a big house or a house that's in the boonies. What's going on during these big fires is we like those houses, the big houses away from help, if they're sprinklered. That's a huge thing. So by code, they may say that needs to be sprinklered as well, especially in these new codes. Anything past 2006, 2010, around those areas, those years, a lot more sprinkler, much more fire protection need to be adhered to if it's being built then. Fire codes require them when a building exceeds a certain size, just touched on that. And then insurance companies offer reduced rates with sprinklers, which is a good idea. The NFPA, know this, the NFPA, National Fire Protection Association, know that. You'll see that for tests and you'll see the rest of your career. National Fire Protection Association. NFPA, National Fire Protection Association, has the standards for all types of different things, from anything in the fire service, from clothing to turnouts, to helmets, to hoses, to fire engines. It's all about the NFPA. And the NFPA 13 is the standard for installation of sprinkler systems. This covers all aspects of system design, including components, water supply, and fire pumps. The NFPA 13A is a recommended practice for inspection, testing, and maintenance of sprinkler systems. The NFPA 13A covers guidelines for the upkeep and inspection of automatic sprinkler systems. So that's 13A. 13D is a standard for installation of sprinkler systems in one or two family dwellings or mobile homes. 13E are recommendations for fire department operations properties protected by sprinkler or standpipe systems. We'll cover standpipes in another part. And then 13R, NFPA 13R, is the standard for installation of sprinkler systems in residential occupancies up to 4 stories in height. Residential being where we live. Apartments, homes, that's what residentials. So know 13, NFPA 13, 13E, 13R, know those types. Components of sprinkler systems. Sprinkler systems are simple. They can consist of 3 things. 1, a water supply. 2, distribution piping. And 3, a number of automatic nozzles from piping called sprinklers or sprinkler heads. So water supply, distribution piping, and sprinkler heads. Those are your 3 systems are made of. The functional names of the sprinkler piping, which I gave you on the schematic, okay, earlier. Remember the schematic, the picture. I'll go back to it so you can freeze and take a picture if you like. All right. And the functional names of the sprinkler piping is the water supply main, the riser, the feed main, the cross main, and the branch line, and of course the sprinkler head. There are 3 types of materials that sprinklers or piping is made of: ferrous metal, copper tubing, and PVC. PVC being plastic, polyvinyl chloride, PVC. Basically plastic tubing. So ferrous metal, copper, or PVC piping is what sprinklers are made from. The sprinkler is also known as the sprinkler head. The sprinkler head senses the fire, reacts to the sense, and delivers water to the fire area. I'll show some pictures later on, and you'll see pictures on that PowerPoint. I got a PowerPoint that a student did. It covers all different sprinklers. And again, I'm trying to show that video if I can download it. I'll cover all this stuff, give you a good visual. The sprinkler head components consist of 3 things: the heat-sensitive device, deflector component, and the discharge orifice or water discharge rate. So a sprinkler head component is the heat-sensitive device, deflector component, and the discharge orifice or water discharge rate. Know those 3. I'll go over each one. First being the heat-sensitive device. The most common type of heat-sensitive device is, know this, fusible link. The most common type of heat-sensitive device is the fusible link. The fusible link has a solder link with a low, precisely established melting point. Other heat-sensitive devices are a frangible or glass bulb. It's like in a little glass with a bulb, and which will expand and break when heated. And then the fusible alloy pellets, kind of metal pellets, alloy pellets, and chemical pellets work like fusible links. When they reach a certain temperature, they melt, pop, and then the sprinkler will activate and flow water through them. The second type of sprinkler head component is the deflector component. Imagine like an umbrella or something kind of, imagine when you're spraying water to wash your car, you put your thumb on the nozzle, okay, to get that kind of spray. That's that sprinkler component we consider. The deflector component, it's attached to the sprinkler frame. It converts the water into a spray pattern. There are other types of sprinkler types that deflect or locate the water differently, i.e. the pendant, the sidewall, and upright sprinkler heads. I'll show a picture of that. I downloaded a PowerPoint one of the students did on sprinkler heads itself. Give you pictures of all different types of sprinkler heads. Don't really have to worry about the rates, but just what the pictures of what each type of sprinkler head there is. And each of them direct the water differently for different types of rooms and occupancies. And then lastly, the third type of sprinkler head component is the discharge orifice and water discharge rates. This is the amount of water discharged by a sprinkler head. The amount of water discharged by a sprinkler head. And this is determined by the size of the discharge orifice and pressure available. Quantity equals K, P equals Q equals quantity, P pressure, K discharge orifices. Basically, don't need to know, but understand it. It's how sprinkler engineers figure out what kind of pressures they need and what type of water flow they need to get that sprinkler head to activate properly and to put out a certain amount of fire or certain type of occupancy to extinguish the fire. Temperature ratings for sprinkler heads. There's operating and activation temperatures vary from 135 degrees to 575 degrees Fahrenheit. 135 to 575 degrees Fahrenheit. Okay, the temperatures depend on the environment, i.e. an attic versus a basement. So if it's 135 degrees, that's probably like a residential home, right? But if it's 575 degrees, that may be a lumber yard, okay? So we don't want to activate too soon. The most common temperature is 165 degrees Fahrenheit. Know that. The most common temperature of activation of sprinkler head is 165 degrees Fahrenheit. Know that. Temperatures should be stamped on the sprinkler head. Sometimes on the head of the sprinkler head, they'll show a number. We'll say 165. That's that activation temperature. Sprinkler response time. Know this. The relative speed of operation is evaluated by the RTI, Response Time Index. RTI. Know that. The RTI is the lower the number, the faster it will respond. That's the RTI. Valves. There are several types of valves. There's control valves. These are used to shut off water and supply the system. They must be placed in an open position. Fires take off in sprinkler buildings when they're not. Indicating valves. These are show where the system situation on or off, i.e. the OS and Y valve. Know that. OS and Y stands for the outside screw and yoke, outside screw and yoke, or the outside stem and yoke. OS and Y. These are threaded portion stem and the outside, the yoke when it open. So when it open, meaning there'll be a screw pattern. There'll be a picture of this in one of the PowerPoints. Now there'll be a screw like this and then a wheel. If it's upright like this with a wheel, that means it's open. If the wheel's to the top, that means the system is closed. We always want that to be open unless they're being repaired. Most of the time, we want it open. PIV valve, post indicator valve. Know that. PIV, post indicator valve. It's either open in a glass, we'll say open, or shut. Open or shut, not closed, open or shut. And we'll say in that little glass. PIV, post indicator valve. The WPIV is the wall post indicator valve, and that's the arrow whether it be either open or closed. And the indicating butterfly valve was this one with the indicating paddle valve. It's like it has two big paddles, like it looks like a butterfly as you rotate it. The operating valves, they are used to make sure the system operates. The check valves, these limits the amount of water to one direction. It prevents recirculation or backflow of the water back to the municipal water system. They also protect against water surges. So the check valves prevent that water be backflow. So when they're a wet system, when they're charged all the time with water, the check valve will make sure that water will not go backwards. It'll always stay forward. Globe valves, these are small hand wheel type valves, mostly used on test valves, and they use opposite threads. So in the fire service, righty-tighty, lefty-loosey. Know this, maybe testing on it, but you're going to see it. Righty-tighty, as you turn anything, or a screw, you're going to turn right. That means you're tightening it, okay? When you're loosening, you're going left, lefty-loosey. So you're loosening, okay? And because of firefighters, we do things at 3 o'clock in the morning. There'll actually be a picture. It will say open arrow, lefty, closed, righty, okay? Because we got to learn this stuff, and we do stuff very late at night at times, so we need to know that. Automatic drain valves, these are drain water from their Siamese connections. Water goes one way and from two branches after its use. I usually draw a picture of the difference between a Siamese connection versus a gated Y. Siamese connection has two pipes going into one, okay? Two pipes going into one, and the gated Y has one pipe breaking out into two. That's the opposite of the two. So Siamese, two pipes going into one. Gated Y has one pipe branching out to two. Types of sprinkler systems. They're wet pipe, and now we're in the meat of this, sprinkler systems. There's 4 types of sprinkler systems. There's the wet pipe, the dry pipe, the deluge, and the pre-action system. The wet pipe system is charged fully with water at all times. All the time there's water flowing through it. All the time. And that's primarily what most sprinkler systems, especially in California, areas where it's not a freezing temperature, but most of our systems are wet pipe systems. The dry pipe system has air that replaces the water. So that means they may be in frozen temperatures. So they'll have a dry pipe system. I have not dealt with that in my career, but that's air to charge system. The air pressurized system holds a clapper valve to prevent water to enter it until it's released. We'll talk more about each one. The deluge system, that's there's no water in the system like a dry pipe until a sprinkler head a sprinkler head is activated, and then a large amount of water sprays out of every sprinkler head. Every sprinkler head, that's deluge. So you'll see those like in lumber yards, the deluge system, where you have one sprinkler head. They don't just activate one sprinkler head, they all go off. If one goes off, they all go off. Make a big mess, but again, the reason for big areas it's going to burn heavy in, like I said, a lumber yard or a municipal types of weapons, that kind of stuff, where you need a lot of water, copious amounts of water, as they say. And then your last type of sprinkler system is your pre-action system. It's more technologically advanced. The piping is normally dry to prevent water damage. That's a dry system. Pre-actions are usually used in computer or document storage facilities because we don't want to damage the area with water. When those sprinkler things activate, for some reason they go off, water damage is bad. So a pre-action system is much more technologically advanced, so we don't want to damage an area where there's documents, a library, or for that matter, computer systems and such. So pre-actions has a much more technologically advanced areas. The wet pipe system, the first type of sprinkler system, is the oldest and simplest and most reliable system. The wet pipe is the oldest and simplest and the most reliable. It can be installed in any and they don't freeze. Some have antifreeze within the system. Areas of 40 degrees, average temperature of 40 degrees Fahrenheit and above. The wet pipe equipment has an alarm check valve, which is used to activate an alarm when one or more sprinklers activate. It has a retard chamber. There's a small tank to absorb the small amount of water flow to delay the alarm operation. It has a water flow indicator and detectors. Detects whether water flows through the piping if activated. Remember that on the schematic? Has like a little bell on the side of the wall there. That's your water flow alarm right here, I think it is. Water flow alarm. No. Water flow alarm right here. Okay. And see that little bell right there? That's your water flow alarm. Okay. And then your alarm check valve. Again, they're down here by the riser. Down here, alarm check valve right over here. Okay. And then your water flow indicator. Oh, I just went over that. Sorry. Okay, so understand that. You may see that again. I'm not sure. I forget. But understand those. The local and fire department notification systems have a water motor gong, activates water when water flows through a motor wheel and then sounds the bell. You'll see a lot of those in schools. Whereas the water flows through it, you'll hear like a dinging sound. Will it slowly be ding, 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 because water's flowing through it. The electric indicators contact ADT, alarm company, and other alarm systems. We'll cover all about the systems, fire alarm systems, stuff like that late at the very end of our class. And you're reading about it in your homeworks. Now, dry pipe system, the second type of system. The dry pipe sprinkler system, it's a sprinkler system where air replaces the water and is usually used in freezing cold temperatures. 40 degrees below, average temperature 40 degrees below Fahrenheit. Sometimes it's important to have a heated portion of the system to avoid the freezing. The system area is forced from air pressure to hold the clapper valve so the water is shut off until activated, meaning down the bottom of the system, down the bottom, oh, that's my bad picture, sorry. Down at the bottom here, okay, this will be blocked off. It'll be blocked off. Because it's 6 feet under is good, there's no freezing temperature, so it'll be blocked off. There'll be some kind of valve here, okay? Once a sprinkler is activated, then this valve quickly opens. And that's when the air is kicked out and replaced with water, okay? That's on the dry pipe system. The system uses force from air pressure to hold the clapper valve so the water is shut off until activated. The dry pipe valves have 2 clappers to shut the water off, and then what they call quick opening devices. Know this. The quick opening devices are located in the large dry pipe system. It will take several minutes for the water to flow through water all the way through source to the most distant sprinkler head. So there are 2 types of quick opening devices to get those heads to activate quicker. So imagine if you're, like I said, a Home Depot, a huge building, or Macy's or Nordstrom or something like that, a huge building. You're talking about a sprinkler head all the way further down at the 4th level or whatever it is. You want that to activate quickly. So a quick opening device, there's 2 types of quick opening devices. There's an accelerator and the exhauster. The accelerator opens a valve within 10 to 15 seconds. The accelerator opens a valve within 10 to 15 seconds. The exhauster will open the valve quickly and then exhausts all the air out and replaces it with water. So the accelerator and exhauster are the two types of quick opening devices. Know that. Deluge system. This differs from the wet and dry systems by having all the sprinklers on this piping system have open leads with no fusible links. So when the valve is tripped, water enters the system and dumps water through every sprinkler head. Not just one or two, every one of them. That's on the deluge system. Fire detection systems may be heat, smoke, or flame. The detection systems control the valve through the tripping device. This is unlike the wet or dry system, which is each individual sprinkler head to activate. Deluge systems are used to dump a large amount of water quickly as a highly flammable or high hazard occupancy. We'll go over that later. Deluge systems usually have fire pumps. We'll talk about fire pumps later next week, or pardon me, after this segment. Next part. Where are the deluge systems located? Know this. Deluge systems, types of systems. Deluge systems are used for, know this, aircraft hangars, woodworking shops, cooling towers, ammunition storage, manufacturing facilities, and lumber yards. Okay, that's your deluge systems. There are three ways of operating the deluge system. Know them. Three types of ways of operating the deluge system: electrical, pneumatic, and hydraulic. The electrical transmits electrical signal to the valve, which trips the deluge valve clapper. Pneumatic is the combination of pneumatic and mechanical. This operates on an imbalance of pressure. The change of pressure activates the system, and the hydraulic change the deluge valve differential to pressure. Then we're going into the last type of sprinkler system, and that's the pre-action. Pre-action systems are used when water damage potential is too great, i.e. computer rooms or document storage. Pre-action systems will only activate when an indication is received from the fire detection device. Pre-action systems piping is usually dry, and the piping is under low pressure. Okay, we got those four. Now we're talking about water supply. Water supply. Every sprinkler system must have an adequate water supply of water, volume, pressure, and reliability. The types of water sources. Know these. There's municipal systems, like a reliable source of water, like over here is we have San Francisco Water Department, East Bay Pump, East Bay Mud, where I worked in East Bay, and El Cerrito, Richmond, Oakland, such. Those are big examples of municipal East Bay muds. There's standby pumps connected to large static sources. There's elevated tanks, known as gravity tanks. Sometimes you see, like in that football movie, we'll say the town on Texas, Odessa, Texas. Now there's a gigantic tank with the name Texas. That's a gravity tank. Elevated tanks, also known as gravity tanks. Pressure tanks have large tanks of water under pressure, and natural water sources, rivers, lakes, and ponds. So know these different types of water supplies. Now, understanding the terms. Again, they didn't go over this in books, but I'm going this for you guys to understand this so you know this later in your careers. You need to understand these types of terms. These terms are volume, pressure, PSI, and GPM. Volume is the amount of water or flow of water. The flow of water, that's the volume. The pressure is the force the water's under, okay? We measure the pressure measurement of pressure is the pounds per square inch, PSI, pounds per square inch. And then we measure the flow or the volume, the measurement of flow of gallons is gallons per minute, GPMs. So the volume is the amount of water or flow of water, okay? The pressure is the force the water's under. The GPM is the flow, measurement of flow, gallons per minute. And the PSI is pounds per square inch, the measurement of pressure. Need to know and understanding of all that through the fire service, okay? The design of the sprinkler system, they are designed depending on what type of occupancy has to be protected. The design is determined by types of sprinklers, sprinkler spacing, type of piping size, pipe hangings, supports, pipe hangers, supports, valves, alarms, drains, and other details. All this design work is mostly done by the, know this, FPE or fire protection engineer, and not by an outside contractor. No outside contractors do that. The fire protection engineer takes care of all this. They design the whole system. Know that. Occupancy classifications. What you need to know about occupancy. Occupancy is defined as the intended use of the building. Occupancy is the intended use of the building. Occupancy. So if I'm having a dry cleaning, that's my occupancy, dry cleaning. If it's educational, it's a school. That's the occupant, the intended use of the building. Know that. Occupancy classifications, what type of building you're protecting. There's light, ordinary, and extra hazards. The light occupancy classification is churches, hospitals, offices, apartments. They are low hazards. When they're ordinary, and there's two categories of ordinary. There's bakeries, canneries, electric plants, 8-foot maximum. The second type is cereal mills, printing and tire manufacturing. That's 12-foot max. That's your ordinary type. And then your extra hazards also have two categories: board manufacturing, sawmills, textile packing. The other type of category is the flammable liquid spraying, varnish. That's where the painters of your car have a certain small little room where they spray paint the car. That's your flammable liquid spraying, varnish dipping, and your flow coating. Just know the three types of occupancy classifications: light, ordinary, extra hazard. The sprinkler spacing is on an NFPA 13 and contains the rules. So what you have is you have light occupancy hazard, they have light hazard occupancies, ordinary hazard occupancies, and extra hazard occupancies. So on a light hazard occupancy, the individual sprinkler heads protect up to 225 square feet, meaning 15 by 15 square feet. So one sprinkler head will cover 25 square feet. So they have when it comes out, it will put out 225 square feet of water. Does that make sense? The ordinary will have 130 square feet plus, 13 by 10, okay, of water, meaning it's smaller because you have more material, right? And then extra hazard, you'll have 100 square feet. I mean, it's much more condensed because you have a much higher, denser, a greater fire load, a higher grade of catching fire and such. Hence the light, ordinary, extra hazards. So that's what they mean by sprinkler spacing. So if I'm going to space my sprinkler from one location to another, I'm going to space it out. I can space it out longer if it's a light, a church or hospital, but I got to keep it closer if it's a flammable liquid spraying or a sawmill or textile. It's got to be closer because that has a higher flammability. I'm going to have more sprinkler heads in that building. Does that make sense? Again, at any time you want to go over a question, write it down, text me, and we'll talk about it. Or email me and we'll go over it and I'll go more clarification. So remember my email, remember my texting, okay? So understand the difference between sprinkler spacing and the light, hazard, ordinary, and extra hazard. So that's NFPA 13 again. Sprinkler pipe sizing. The most important part of the sprinkler is the pipe. Know that. The most important part of the sprinkler is the pipe. You need to know what size pipe you can adequately or overly support the amount of sprinklers there are. Example, a 6-inch pipe for 10 sprinklers. That's too much. A 1-inch pipe for 10 sprinklers. That's too little, right? So if you have 10 sprinklers, you need a bigger, thicker pipe. When you have one sprinkler head, you can go a little smaller, okay? So just keep that in mind about sprinkler pipe sizing. The pipe schedule method, know that. The pipe schedule method specifies the pipe size that must be used to supply a given number of sprinkler heads. The discharge density, know this too, is the required design of a sprinkler system and is expressed in gallons per minute, GPMs, per square foot, or liter per minute per square meter. Example, and you don't need to know this, but this is where we talk about the Q and quantity, coefficient, all that kind of stuff, where the fire protection engineer goes over. The example is a discharge of 0.20 GPM over 2 square feet over an area of 2,000 square feet. Is the total flow is 400 gallons per minute. So an example, if you have a given sprinkler discharge of 25 gallons per minute as part of an ordinary hazard system, meaning like a cannery with sprinklers spaced at 130 square feet, meaning one every 13 by 10 square feet, that means 0.19 GPM slash 2 feet, hence 0.20, and that's how they get the 25 PM. And that's how these fire protection engineer determines the spacing of that pipe, or the spacing of these sprinkler heads. Okay, just understand that. But know pipe schedule method, discharge density, and know about the different type of sprinkler spacing. Moving on. Sprinkler systems for industrial storage occupancies. Enormous size of modern warehouse presents severe fire control problems. When I was researching this class, I looked at the book that I just showed you at the beginning, and they talked about 3 different places that had a huge fire based on sprinkler issues. That mean it took off these big, large buildings. One was a service merchandise warehouse in Garland, Texas. Another was a Kmart distribution center in Falls Township, Pennsylvania. And the last one was a Safeway warehouse in Richmond, California. And guess who was put at that fire the next morning? Right here. Okay? So those examples of huge buildings when the sprinklers had failed out and these things took off on these big kind of huge fires. So higher loss potential can be attributed to general conditions. Large undivided areas, large concentration of value in single fire area, and then very high stockpiling with narrow aisles. Hence what happened in the Richmond Safeway fire. When they did the investigation, apparently they said different stuff, but they speculated that when they're loading something, it kind of clipped one of the sprinkler heads, it deactivated it, and then they were stackpiling material. They're stacking it too high, okay? Meaning here's the sprinkler head. You have to have a certain amount of distance, spacing, between the sprinkler head and your material. At least, and know this for the test, is you need at least 18 inches spacing between a sprinkler head and the material. But you have a Safeway warehouse, you may have to like 24 inches or 2 feet or so. But in that case, the material was stacked, the sprinkler was activated, caused damage, it took off, and all the things got fire. And when the sprinkler activated, it didn't put enough water to suppress the fire. That was the idea. So no, that's just general understanding. There are 4 general hazard classifications based on the behavior of typical items. Know them, classes 1 through 4. All different classes will be stored separately and replaced in more exclusive sprinkler areas. The storage methods, there are 4 storage ways of a warehouse. Bulk storage, that's items placed on bins or silos, possible dust explosions, sugar, flour, plastic, pellets like in the Richmond Polymer fire. If I was teaching a class, I'd go more in detail. I was at that fire too. But that's like bulk storage. That's one storage method. They have solid piling, means stacking merchandise on cartons on top of each other. Then they have pallet storage, individual containers on top of pallets. And then the pack storage is structural framework where containers are stored. And that's basically what happened in the Richmond fire. All these were stacked up. We go over to talk about inspection of sprinkler buildings. If you guys, I have all these different types of forms that we went over that I actually had used when I was doing prevention, fire prevention. There's sprinkler tests. In any case, I'll go over each one, but I have if you guys are interested, I pass those out in my class. If you're interested, I don't test you on them. It gives you a breakdown of how we test each sprinkler system and how we go about that. The sprinkler tests are every 5 years. Know that. Every 5 years, a sprinkler test has to be conducted on one of these occupancies. Know that. Once every 5 years. Must have 18 inches of spacing. Remember about that? Between the sprinkler head and the spacing. At least 18 inches of space between the sprinkler and the stored product. Know that. And then restoring the sprinkler system. It is best for the fire department to restore the system if one or more sprinklers go off. However, the fundamental responsibility, know this, the fundamental responsibility for restoration of the system belongs to the building owner. You get wet replacing the sprinkler heads, but the fire department can replace them. Our job when the sprinkler heads go activate is to shut the system off, replace the sprinkler head, and then we don't have to put it back in the system, which we most often do. But we have to put the onus on the building owner. But we usually can start it up. But once we do, our main job is to cause any water damage, shut the water off, shut the whole system down, replace the sprinkler head, and then we can reactivate them. But we like to. What I've been told by my fire marshal was they want to know if it's been checked, so that let the building owner let us know, and we put it out of service. But in that case, we can restore it and put it back, flow the water back, but we want the onus back to them so we know of a record of what's going on with the building. That's what my fire marshal, my boss, was talking about. In any case, our job is to make sure the system is shut down, shut down the damage, replace the sprinkler head, and then we can open it up. But we have to ultimately the building owner had to let us know or share that information with both of us. Residential sprinklers, fire department operation sprinkler occupancies. Again, I have some handouts if you want on that. Let me know. Residential sprinklers, a small little item on that. According to the NFPA, 80% of fire fatalities occur in residential sprinkler occupancies. Know that. And according to the NFPA, 80% of our fire fatalities, people who die in the fire, is in residential sprinkler buildings. Know that. 13D, NFPA 13D, 13R involve residential sprinklers and their use. Know that. Residential sprinklers differ from those in commercial occupancies. Residential mean homes versus a supermarket or store. Commercial occupancies. The main difference is, know this, the sensitivity and speed of operation. Sensitivity and speed of operation. Residential sprinklers makeup versus the commercial sprinklers. Know about sensitive speed of operation. Residential sprinklers makeup versus commercial sprinklers. I basically wrote piping 3/4 inches is 1 or 1 inch. Flow 18 gallons per minute versus 20 or 30 gallons per minute. Temperature 165 degrees Fahrenheit versus 125 or 110. And then water supply a 6-inch main versus 1 or 2-inch main for domestic. So meaning residential systems are just smaller pipes, smaller fittings, just smaller because it's a smaller space, a home rather than a commercial occupancy. That's what I'm trying to say. So with that, I also going to do probably a show. I'm going to try and download a residential. It's a good video on residential sprinklers that one of those home repair guys did. I showed that video, but I'll try and download that on email if I can. And that goes over residential sprinklers. And I'll put that on Canvas as well, or I may email it to you. But now that we're done with my lecture, I kind of want to do a quick review. And one of my students who did their presentation, which you're going to have to do at the end of the year, he did on sprinklers. So he talked about Brandon did a good job here. He did about the history of sprinkler systems. Okay, don't need to know this. But again, sprinkler systems have operating for over 100 years, right? 1940s, we don't have to know that. Sprinkler system, the NFPA, since 1990, fire sprinklers have been regulated by NFPA 13. We know that, right? 13R is what? The standard for installation of sprinkler systems for residential occupancies, right? Know that. Components of a sprinkler system. Here's like a little schematic he made. Okay, looks familiar what we talk about? Take a quick look. All right, there's your schematic of what you need in a sprinkler system. Okay, the piping, branch lines, the riser, water supply, all that kind of good stuff. Okay, water supply, distribution piping, number of automatic nozzles known as sprinkler heads. You know the sprinkler piping again. Picture of what we did when we covered. Did a good job on that, on the schematic. Okay, there's your sprinkler piping. There's a schematic just like mine. Okay, goes to a breakdown of the riser, going off to the branch lines off the sprinkler head, and the cross mains, to riser, the cross mains to the branch lines. Okay. Sprinklers are always made of, know this, 3 types of material. Sprinklers are made of 3 types of material. There's the ferrous metal, okay, any type of metal here. There's the copper tubing, like there, and then PVC pipe. So there's 3 types. Sprinklers are made of 3 different types. The ferrous metal, the copper tubing, and the PVC. And sprinkler heads must have a heat-sensitive device, deflector component, and discharge orifice. There's a basically schematic for your sprinkler head. Okay, and again, the PowerPoint shows you all the breakdown of the sprinkler head, what it has a deflector component right down here. Okay, has a sprinkler here, so it's shut off until something activates, whether it be a frangible bulb. Okay, it has a heat-sensitive device, will pop and activate. That's your sprinkler head. Then your heat-sensitive devices. Here's your regular releasing mechanism. Did a good picture of that. There's the different types where it has the deflector component on top. See the deflector component like an umbrella. Okay, so it will activate. If it's a frangible bulb, or in this case chemical pellets, these will melt. The water will pop and flow through here, bounce off the deflector brick and flow down. Okay, the same thing here is your frangible bulb. Okay, there's that solder pellets. Okay, there's your frangible bulb, whereas the glass pellet has like it gets heated in there. That glass will break, and then water will flow, bounce off the deflector component, and spray water downward. Okay, so that's your heat-sensitive devices. Your deflector component. Here's a different type of sprinkler heads. You have here's different types of sprinkler heads. There's your pendant. Okay. There's your sidewall, meaning it's on the side of the wall. Okay. And look at the deflector component. Okay. A lot of hotels have sidewall components. They're on the side of the wall. They're just on the wall hanging. And then your upright sprinkler head, notice the deflector component on the upright is different than the pendant, okay? Your upright means your piping, your branch line right here is off here, it's upright. The sprinkler is upright. So the water will spray up, deflect back down. Your sidewall will spray out and then deflect off this deflecting component and spray outward. And then lastly, this pendant is hanging downwards. Okay, here's your piping here, branch line. And then water will spray and then deflect off this deflecting component, different than this one over here. Okay, see you guys the difference? All right, moving on. Types of valves, we went all over that. Wet versus dry pipe. Wet systems have water flowing through all the time. Dry do not. And your deluge and your pre-action are mostly dry pipe. And most of the sprinkler system today are made of wet systems. And it talks about maintenance. Sprinkler systems have to be tested every 5 years. And what's the difference between the sprinkler head and your material? At least 18 inches. Okay? And I think that's about it. So this concludes sprinklers. I know it's very long. You may want to have done this in pieces, I hope. If you have any questions, again, text me or email me, and I'll be happy to answer it. And again, look at your PowerPoint that you have on Canvas. And if you want more go in detail, we'll go over it. Okay? Thanks for your attention. Be well.